Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is a 3-carbon chain, 2,4-dibromochlorobutane-like structure. More precisely, it is a molecule with C1 bearing CH3, H, wedge, and Br dash. C2 bearing H, wedge, and H dash. C3 bearing H, wedge, Cl dash, and CH3. NaN3 is a source of the azide ion, N3, a good nucleophile. Moving on to the next step. Between Br and Cl, bromide is a far better leaving group in SN2 reactions because CBr bonds are weaker and Br is a more stable leaving group than Cl. Therefore, NaN3 selectively displaces Br at C1. Moving on to the next step. SN2 proceeds with inversion of configuration, Walding inversion, at the carbon bearing the leaving group, C1. In the starting material, C1 has Br on the dash, back, and H on the wedge, front. After inversion, N3 replaces Br with inversion, N3 ends up on the wedge, front, left, and H remains but now effectively on the dash side, meaning N3 goes to the wedge position at C1. And for the final step, C3 is not involved in the reaction, so its configuration is retained H on wedge, left, and Cl on dash, right. Option C shows C1 with N3 on wedge, left, and H on dash, right, inversion at C1 from Br dash to N3 wedge, C3 with H on wedge, left, and Cl on dash, right, unchanged. This matches the SN2 inversion at C1 with retention at C3. A has N3 on dash at C1, which would mean retention not inversion, incorrect. B has N3 on wedge at C1, correct inversion, but Cl on wedge at C3, changed configuration at C3, incorrect. D has N3 on dash at C1, retention, and Cl on wedge at C3, changed, incorrect. Therefore, the correct answer is C. Therefore, the correct answer is option C.